Alright, we want to do long division of this polynomial divided by this polynomial. It looks like normal long division, so it'll look kind of like this. Okay, we have our long division bar. The x minus 3 is what we're dividing by, and you have the 3x cubed to start with. But what you notice here is, you notice an x squared is missing, how it goes from x cubed to x. So we need to put an x squared here. You'll see why later. It won't make sense right now, but we need to put a 0x squared, then we have a minus 7x, and then we have minus 2. So starting with the highest power and going your way all the way down, you need to have each term in it. So if one's missing, you put a 0 of that. And now what we're going to do is long division. So the question is, what times x gives you 3x cubed? Hopefully you can tell that that would be 3x squared, because x times 3x squared is 3x cubed. And then you also multiply 3x squared times negative 3. So watch what happens. When I multiply this times this, I'll put it right here. When I multiply this times this, I'll put it right there. So what you have is 3x squared times x is 3x cubed, and 3x squared times negative 3 is negative 9x squared. And then I'm going to subtract down, just like regular long division. Like regular long division, I now subtract down both these. And what you should notice is that will cancel. And when you subtract down, be very, very careful. 0 minus negative 9 is actually a positive 9x squared. That's very easy to mess up. Now I bring down the negative 7x. Okay, so what times x now gives you negative 9x, positive 9x squared? Well, wouldn't that be x times 9x? So I'm going to go up here and put a 9x above the x. So positive 9x. It's always important that your x squareds are in this column, your x's are in this column. That's kind of important. Anyway, so we go 9x times x is that. 9x times this will be a negative 27x. So we get 9x times that is 9x squared, and 9x times negative 3 is negative 27x. We are going to subtract down both pieces. When you do that, this cancels. Negative 7 minus 27, be careful, that's a positive 20x. It's very easy to mess up, so be very careful with that. Bring down the negative 2. Now, what times x gives you 20x? Hopefully you can see that would be a positive 20. Again, all and then you can tell. Again, all the numbers are in this column, x is this column, and so forth, that they line up. When I multiply that in, 20 times x is 20x, and 20 times negative 3 is negative 60. And I'm going to subtract down. Once again, this is very repetitious. And then negative 2 minus 60 is a positive 58. That's my remainder. So my answer is written like this. It is 3x squared plus 9x plus 20. My remainder is 58, so I write it as 58 over x minus 3. Because like in long division, here's your answer, and you take your remainder and divide it by the divisor. That's right here is my final answer to this problem. Now, for synthetic division, we're going to get the same answer. It's a shortcut that works a lot of times. It's pretty slick. It's kind of useful. To do synthetic division, what we though do is we first got to look at this and think, what would be a 0 if this was a factor of this graph? Because when you're dividing, you're trying to find factors, what factors go into it. So if we divide this into this, if it is a factor, then that means the factor is x minus 3, so the 0 would be 3. So I'm going to take the 0 of this, meaning what would make the 0? So 3. So all that said is I take the 3, and I'm going to write it like this, 3. Then you take each of the coefficients, so 3x cubed. There are 0 x's. There is a negative 7 on the x and a negative 2 on the number. So again, I took the opposite of this, and then I took 3, no x squareds, negative 7x, and a negative 2. And there's this kind of process we're going to go. First thing you're going to do is you're going to bring down this 3. Then what you're going to do is multiply this 3 times that 3 and put it right here. That times that and put it right there. So 3 times 3 is 9. You just kind of moved it up like that. And then we add down. So we're going to add straight down. So 0 plus 9 is 9. Alrighty. Now we're going to multiply 3 times 9 and put it right here. 3 times 9 is 27. Put it right there. So we're going to move that up. That's going to be 27. And then, again, we add down. Negative 7 plus 27 is 20. Great. Now, again, 3 times 20. Put it right there. So 3 times 20, put it right there. That's 60. And we add down. Negative 2 plus 60 is 58. That right there is your remainder. And that remainder is kind of important. And what you should kind of notice is, look at this, 3, 9, 20, 58. 3, 9, 20, 58. Do you see something? These numbers on the bottom here are the coefficients of each piece, and that's the remainder. It's a cool little process that works. It usually is only useful if you have a nice, like x plus some number, x minus some number. It gets complicated when you divide by a larger piece, or even a polynomial at larger degree is really tough. So our answer, if we wrote it out, is going to be the same thing as right here. How I write it out, because if we didn't have this first, how do you know how to write this? So what I know is that's the remainder. So that's how I start. I start with the 58. So I'd write it as 58 over the x minus 3. Once you get the 58 over the x minus 3, because that's the remainder, now you take the 20. The 20 is your first term next. That's the non-x. That's the digit number. So we would put a plus, because that's a positive 58, so plus 20. Then you go to the 9. The 9, well, if that's a 20, that's a number. The next one's an x, then it's an x squared. So that next one would be a 9x. Put a plus, because it's a positive 20. Next one would be an x squared, which would be a 3 in front, and it's a positive 9. So there's your answer. It probably is helpful to start from the remainder this way and think of numbers, x's, x squareds, x cubes, x fourths, and work your way that way, especially if you didn't do this problem first. Now the benchmark, I have you do both of these. Do you understand the answers should be the same? If your answers aren't the same, guess what? You made a mistake, so check your work. These answers should agree if we're doing the same problem 2 different ways.